Good morning, students. In the last lecture, we have discussed average velocity and average speed. In average velocity, okay, we noted one point. Average velocity gives what is average velocity between any time interval. Means how fast object is moving from one station to another station. It does not give velocity or speed at any instant or at any position between two stations. It gives value over a period, not any instant. For example, one vehicle is starting its journey from Anand at 10 a.m. okay, and reaches to Baroda at 12 a.m. Then between these 2 hours, at different location, at different time, what is its velocity? Average velocity does not give this value. For that, we have to define one new quantity, that is called instantaneous velocity and speed. Instantaneous velocity and speed. Now, what is difference between average velocity and instantaneous velocity? Average velocity means velocity over a period. And instantaneous velocity means velocity at any instant, means any particular time. Okay, now how to find instantaneous speed? See, speedometer used in vehicle, okay, it gives instantaneous speed. Speedometer in any vehicle gives instantaneous speed. Why speed, not velocity? Because it is scalar quantity, okay, where you move in any direction, okay. First of all, you are moving in right hand direction and then moving in left hand direction. Then is there any negative sign on speedometer? No, there is no negative sign on speedometer, okay. It measures path length, what is distance traveled. So speedometer measures instantaneous speed. Instantaneous, why? Okay, because as you are moving with time, if you increase your speed, then that increased speed is indicated on that speedometer. Okay, so remember, speedometer gives instantaneous speed. Here we have one example. See, one vehicle is in motion from a point on a straight line. It is origin O. Okay, as time passes, 1 second, 2 second, 3 second, 3.1 second, 4 second, 5 second, 6 second. Its displacement from origin at 0 second, here it is. At 1 second, it is at 1.5 meter. At 2 second, it is at 6 meter. At 3 second, it is at 13.5 meter. At 4 second, it is at 24 meter. Okay, like this. So, with respect to time, displacement is given, and also reading of speedometer is also given, 0, 3, 6, 9, 12, 15, 18 meter per second. Okay, now what we have to find? Suppose we want to know the velocity of car at t is equal to 3 seconds. We know its instantaneous value. At time t is equal to 3 seconds. What is its instantaneous value? 9 meter per second. 9 meter per second. But how to calculate it? How to relate it with average velocity? See, we are taking some examples. First of all, I am taking one time interval. Time t is equal to 3 to time t is equal to 6 seconds. See, t is equal to 3 seconds to t is equal to 6 seconds. So what is time interval? 3 to 6 means delta t is equal to 3 seconds. What is delta t? Delta t is equal to 3 seconds. So during this period, find average velocity. How to find average velocity? Average velocity is equal to displacement upon time. Final position minus initial position upon time. See, final position is at time t is equal to 6, 54. Initial position is at time t is equal to 3, 13.5. So 54 minus 13.5 and divided by what is time interval? 3 seconds. You will get 13.5 meter per second. Clear? Okay. Now, this 13.5 meter per second is not near to 9 meter per second. There is a large difference. Okay, so now we are taking another example. Now if I take time interval t is equal to 3 seconds to t is equal to 5 seconds. So what is time interval? Time interval is 5 minus 3. It will be 2 seconds. It will be 2 seconds. Okay, so see, at 5 seconds, displacement is 37.5 and it is 13.5. 37.5 minus 13.5 divided by 2, then is equal to 12 meter per second. 12 meter per second. See, our value is now near to 9 meter per second. Initially it was 13.5 meter per second. Now it is 12 meter per second. Again I am taking time interval small. See, t is equal to 3 seconds to t is equal to 4 seconds. Means now what is time interval delta t? 1 second. Okay, so if in this period you find average velocity, that is v bar, then it is equal to 24 minus 13.5 divided by 1. It is 10.5 meter per second. So see students, from these 3 example, you can say as we go on decreasing time interval, our calculated value and true value, difference between them decreases. Means calculated value tends to actual value. Okay, if I am taking time interval small, it is 3 seconds, 2 seconds, 1 second. If I am taking time interval very, very small, for example, I have this 1 point, 3.1 second. For that 3.1 second, displacement is 14.415. Then for t is equal to 3 seconds to t is equal to 3.1 second. What is time interval? Time interval is 0.1 second. Time interval is 0.1 second. For this time interval 0.1 second, if I find average velocity v bar is equal to 14.415 minus 13.5 divided by 0.1 is equal to 9.15 meter per second. We can say it is very, very close to this actual value or true value. Clear? So what is conclusion of this theory? Conclusion of this theory is, as we decrease time interval, if we decrease time interval, average value calculated becomes instantaneous value. Average value calculated becomes instantaneous value. Okay, see, so as we go on decreasing the time interval, the difference between calculated value and true value goes on decreasing. Further, if you take time interval very small, less than 0.1 second, hello, your answer will be less than 9.15 and very, very close to this 9. Very, very close to this 9. So see, here, what is conclusion? If we take time interval very, very small, 0.1, okay, if we take time interval very, very small, average value calculated becomes instantaneous value. Then how to define instantaneous velocity? See, if you take limit delta t tends to 0, now what is meaning of delta t tends to 0? Delta t tends to 0 means time interval is near to 0, not 0. Is near to 0. Near to 0 means very, very small, but not 0. Not 0. Again, delta t tends to 0 means value of delta t is very, very close to 0, but not 0. Okay. So if you take limit delta t tends to 0 means time interval very, very small. In such circumstances, average value obtained is called instantaneous value at time t. And in maths, okay, math students, you will study this topic, okay, in the 12th. And for biology students, whatever required differentiation and integration, I will study, okay. I will teach you okay, how to find differentiation and integration. So see, instantaneous value at time t, V is equal to limit delta t tends to 0 delta x upon delta t. What is delta x upon delta t? Delta x upon delta t is average velocity. But what condition we have to apply? Limit delta t tends to 0. Means time interval we have to consider very, very small. So to calculate average velocity, if I am taking time interval very, very small, it becomes instantaneous velocity, and it is represented by V is equal to dx upon dt. This whole term in maths is indicated by dx upon dt. How to read this? Dx upon dt is called derivation of x with respect to t. Derivation of x with respect to t. Derivation of position with respect to time. Derivation of position with respect to time. And it gives rate of change of position with respect to time. Rate of change of position with respect to time. Clear? So it is relation. See, in future, okay, there are numbers of cases in which we have to find average value and instantaneous value. Okay, so in future we will write only one statement. Okay, if I am taking delta t tends to 0, average value becomes instantaneous value. Okay, we will not prove any theory in future. We will not prove any theory in future. We will just write one statement. Okay, if I am taking limit delta t tends to 0, average value becomes instantaneous value. Clear? Now see, this instantaneous velocity is also called only velocity. Is also called only velocity. Okay, and see, for only velocity or instantaneous value, what is notation? Only V. Only V. V bar, it means average velocity, and only V, it means instantaneous velocity or only velocity. Clear? Now, in the next session, we are going to study one important topic. Okay, yes, it is topic of maths, but in physics, you have to use this fundamental of this concept of maths, and it is very important. Okay, it is very important. It is called derivation, differentiation. Okay, so what is differentiation? How to use it? We will see with numbers of examples. Pause your video and write down from board. Okay, now what is differentiation? Some formulas for differentiation. See, we will study. D upon dx, x raised to n. First of all, understand, see, this d upon dx, this term indicates differentiation is with respect to what? Here, as it is d upon dx, it means here differentiation is with respect to x. D upon dx means differentiation is with respect to x. If I write d upon dt, then it is differentiation with respect to time. If I write d upon dv, then it is differentiation with respect to v. Okay, so first of all, understand, d upon dx, it means differentiation with respect to x. Now it is x raised to n, means it is one function of x. Okay, see, it is one formula, x raised to n. It is one formula, okay. It is function of x. Now what is its answer? D upon dx, x raised to n is equal to x raised to n is power. You have to take this power as its coefficient. You have to take this power as its coefficient. Okay, so x raised to n is equal to n as coefficient. X, you have to decrease one power. You have to decrease one power. So what is answer of d upon dx of x raised to n is equal to n x raised to n minus 1. Whatever power you are given, you have to write as coefficient. Okay, you have to write as coefficient and you have to decrease one power. See, we will see some examples. If you are given d upon dx of x raised to n, differentiation is with respect to x. Here function is also of x. X raised to 10 function is of x. Okay, then how to find this? Is equal to, what is power of x? 10. Then 10 as its coefficient. Okay, now x raised to 10, you have to decrease one power, means 10 minus 1. So how to write this? It is 10 x raised to 9. Clear? Okay, you can also write directly this step. Okay, see another example. D upon dx of x raised to 5. How to write this? See, differentiation is with respect to x. What is function x raised to 5? This 5 power as its coefficient x, you have to decrease one power, that is 5 minus 1 is equal to, it is 5 x raised to 4. Clear? Okay. Next example, d upon dx of x square is equal to x square 2 coefficient x raised to 2, 2 minus 1, so it is 2 into x. Clear? See, it is easy. Okay, d upon dx of x raised to 10 is equal to 10x raised to 9. D upon dx of x raised to 5 is equal to 5x raised to 4. D upon dx of x square is equal to 2x. Now what about d upon dx of x? D upon dx of x, see, is equal to, you have to follow what is your general formula, okay? That is n x raised to n minus 1. Here d upon dx of x means I can write d upon dx of x raised to 1. Yes or no? Yes. 1 coefficient. Okay. And x raised to 1 minus 1 means is equal to 1x raised to 0. Now students, what is x raised to 0? X raised to 0 is equal to 1. X raised to 0 is equal to 1. So your answer is 1. So your answer is 1. Okay. Any quantity, any term raised to 0, it's 0 power. Its answer is 1. Okay. So d upon dx of x, its answer is 1. Its answer is 1. Okay. So it is very easy. You have to take power as coefficient and decrease one power. Now if you are given term like this, for example d upon dx 5x raised to 10. Then what is matter? See, differentiation is with respect to x. It is 5x raised to 10. This 5 is in multiplication with this x raised to 10 function. And it is constant. This 5 does not depend on x. This 5 does not depend on x. So if you are given such constant in multiplication with this function, you can take them out of differentiation. Means you can write d upon dx x raised to 10 like this. Okay, you take this constant outside differentiation, then is equal to 5 d upon dx x raised to 10. Now what is differentiation of x raised to 10? That you know. Okay, here it is 10 x raised to 9. So is equal to, it is 50 x raised to 9. Clear? When you are given such constant multiplied with function having x. Okay. Another example is equal to d upon dx of a raised to x raised to 5. How to write directly? See, differentiation is with respect to x. Term is x raised to 5. As this a is constant, as it is. What is differentiation of x raised to 5? 5x raised to 4. Simple. It is 5x raised to 4. This term, d upon dx of px square is equal to, differentiation is with respect to x. P is constant, x square, then P as it is. What is differentiation of x square? It is 2x. Easy. Okay, in this term, d upon dx of rx is equal to, differentiation is with respect to x. Here you have one term x and r is at coefficient. R as it is. What is differentiation of x? 1. Then your answer is only r. Then your answer is only r. Okay. If you have term like this, d upon dx of 5. See, in each and every case, 1 2 3 4 5 6 7 8, d upon dx of some function, and that function is of x. That function is of x. Here it is d upon dx of 5 only. Means this 5 is constant, it does not depend on x. So differentiation of such constant having no x is equal to 0. Now you may ask, why d upon dx of 5 is equal to 0? See, we can write this term as d upon dx of 5 is equal to d upon dx of 5 x raised to 0. See, I can say x raised to 0 is equal to 1. Then I can write 1 is equal to x raised to 0. Then here d upon dx 5 x raised to 0 is equal to 5 out of differentiation. D upon dx of x raised to 0. If you apply your general formula, then this 0 you have to write in as coefficient. Then it is 0. Yes or no? Yes or no? Any quantity, any value multiplied with 0. So your answer will be 0. Your answer will be 0. Okay? It is 0 minus 1. So your answer is 0. So your answer is 0. Clear? So you have to remember, if differentiation is of any constant, then its differentiation is 0. Similarly, what is d upon dx of a? If a does not depend on x, again it is 0. Again it is 0. Okay. Now d upon dx of x raised to minus 10. When you are given this minus power, then you have to apply general formula. Minus 10 as coefficient, x minus 10 minus 1, so is equal to minus 10 x raised to minus 11. X raised to minus 11. Clear? Next, d upon dx 1 upon x raised to 5. 1 upon x raised to 5. You can also write this term as d upon dx x raised to minus 5. Yes or no? 1 upon x raised to 5 is equal to x raised to minus 5. And what is that differentiation of x raised to minus 5? Like this. Okay, is equal to minus 5 x raised to minus 6. Why minus 6? Why minus 6? Think. Last one, d upon dx x raised to minus 5 by 2 is equal to power minus 5 by 2. Okay, like this. And x raised to minus 5 by 2 minus 1. Okay, now to calculate such things, you must know fundamentals of maths, basic calculation. Okay, so is equal to minus 5 by 2 x raised to minus 7 by 2. Clear? So it is about differentiation. It is only one formula. D upon dx of x raised to n is equal to n x raised to n minus 1. Okay, if you know this, then you can easily find what is average velocity. Clear about this topic? If you have any doubt in this topic, okay, send doubts on my WhatsApp number, because it is important topic. Okay, from next lecture we have to calculate some illustrations and examples based on differentiation. And hello, physics is king of science. Okay, in this physics we have to use maths. Differentiation and integration. Integration is also one of the most important topic. Okay, we have to study both topic to apply in physics. Okay, pause your video, write down from board. You have some sums in homework. You have to find differentiation of these 10 questions. Okay, and this homework you have to send on my WhatsApp number. Okay, important message છે students for you. Yes, physics માં maths નો use બધો બહુ આવવાનો છે. Okay, don't worry. મેથ્સના સ્ટુડન્ટ આ બધી વસ્તુઓ ભણવાના છે. વોટ ઇઝ ડિફરન્શિએશન એન્ડ વોટ ઇઝ ઇન્ટિગ્રેશન. ફોર બાયોલોજી સ્ટુડન્ટ્સ ડોન્ટ વરી. ફિઝિક્સમાં જેટલો પણ મેથ્સનો યુઝ આવે છે, વોટ ઇઝ ડિફરન્શિએશન, વોટ ઇઝ ઇન્ટિગ્રેશન, હાઉ ટુ યુઝ લોગેરિથમિક, ઓકે, એ બધું જ અહીંયાથી ડિટેલમાં કરાવીશું. સો અગેન બાયોલોજી સ્ટુડન્ટ્સ ડોન્ટ વરી. જેટલા બી મેથેમેટિક્સના ટોપિક ફિઝિક્સમાં યુઝ થવાના છે, આઈ ગેરંટી યુ એ બધા જ હું તમને બહુ જ ક્લિયર કરાવીશ. ઓકે, સો ડોન્ટ વરી. એવું કંઈ જ ના સમજશો. મેથ્સવાળા સ્ટુડન્ટના ઇઝી પડશે, અમને નહીં પડે. તમને એટલું જોરદાર આવડતું થશે, બહારવાળા એવું કહેશે કે તમે મેથ્સના સ્ટુડન્ટ છો. અગેન બીજા અમુક પોઈન્ટ્સ છે. યસ, મંડેથી સ્ટાર્ટ કર્યું છે. ટુડે ઇઝ ફ્રાઈડે. 5 ડે થઈ ગયા છે. આ 5 ડેમાં આપણું જે 3rd ચેપ્ટર છે એ ખાસું બધું ચાલી ગયું છે. એઝ વેલ કેમેસ્ટ્રી, બાયોલોજી અને મેથ્સમાં પણ બધું બહુ ચાલી ગયું હશે. જો તમને ખબર હોય તો તમારું વોટ્સએપ ગ્રુપ બની ગયું છે. જેનું રજિસ્ટ્રેશન થયું છે એવા સ્ટુડન્ટ્સનું વોટ્સએપ ગ્રુપ બની ગયું છે. અને એવા સ્ટુડન્ટ્સના હવે ઝૂમ એપ્લિકેશન પર આપણે વિડીયો કોલ થ્રુ ડાઉટ સોલ્વિંગના સેશન પણ રાખવાના છીએ, જે આ વીકથી જ સ્ટાર્ટ થઈ જશે. તો જે સ્ટુડન્ટ્સનું રજિસ્ટ્રેશન થઈ ગયું છે એ સ્ટુડન્ટ્સના વોટ્સએપ ગ્રુપ બની ગયા છે. એ સ્ટુડન્ટ્સના ઝૂમ મીટિંગ પર હવે ડાઉટ સોલ્વિંગ સેશન્સ ચાલુ થઈ જશે. ક્લિયર? તમારે જે કંઈ બી અહીંયા બોર્ડ પર લખેલું છે એ બધું જ બોર્ડ પર લખેલું નોટબુકમાં લખવાનું છે. અને એ નોટબુક ના પિક્સ પાડી પીડીએફ ફાઇલ બનાવી અમે તમને એક લિંક પ્રોવાઈડ કરીશું. ઓકે, તમારું જે વોટ્સએપ ગ્રુપ છે ને રજિસ્ટર્ડ સ્ટુડન્ટ્સ માટે, એ ગ્રુપમાં એક લિંક આવશે. તો શું કરવાનું છે? અત્યાર સુધી તમે જેટલું બી વસ્તુ લખી છે ને એ બધી જ વસ્તુની તમારે એક પીડીએફ ફાઇલ બનાવવાની. અને એ પીડીએફ ફાઇલ છેલ્લે લાસ્ટમાં એક ઓપ્શન હશે અપલોડ ફાઇલ, એમાં તમારે અપલોડ કરવાની છે. તમારું આ બધું જ હોમવર્ક ચેક કરવામાં આવશે. જેનું ઇનકમ્પ્લીટ હશે ઓર કંઈક કરેક્શન હશે એને તરત કોન્ટેક્ટ કરવામાં આવશે કે યુ હેવ ટુ મેક ધીસ કરેક્શન. ક્લિયર?